And team, you can go on mute. Yeah. Hi, all. Good morning. Hope you are doing well. Have seen some of you are doing good practice. Keep it up. And I observed that few students are not able to write like if, else if, and some for loops. They have some confusion. Don't worry. I will conduct some practice sessions so that I will closely check what you are doing. I will help you. Okay. Today, just focus on what we are discussing. Today, we are going to learn how to check a number is a prime number or not. This is the most important interview questions. Even if you are studying a BTech first year or something, definitely it will be a there is a high chance that you can see this question in examinations as well. So first of all, so normally what normally students do, right? So let me open the live also if anyone is there. So normally, whenever you get this kind of question, first students will start writing a for loop, and after that, just try to implement a inner logic. So sometimes it's really tough for a beginner. I'm saying if you are a beginner, okay, just follow these steps. It will be more helpful. Once you got the confidence, yes, you can start directly. Okay, first of all, you should know, you should understand the question properly. So if I give a number, if I give a number, you should write a program to check whether that number is a prime number or not. Okay, prime number or not. Many students, okay, they have written logic like output is coming displaying like even numbers. Okay, because if you're getting if you're not getting the desired output, you should think the logic where you have written wrongly, and you can write program again. Okay, so this is the first step because so far we have learned only if and for loop and very um, simple basic things. So now at least we are going to write a good program. Okay, prime number, first of all you should know what is a prime number. Suppose if I take is a 21. Okay, so tell me a 21 is a prime number or not quickly, or there in the session. 21 is prime number or not? No. Okay, so you know mathematics already. Just looking into that number, you can say that this is the prime number or not. Suppose the 17, you can say this is the prime number. Suppose if I give a 171, tell me 171 is a prime number or not. 17 or 21 you can guess easily. 171, what about 171? What about 1281, like that? So it's very difficult to guess what is a prime number. So even though we know the characteristics of the prime number, first we should focus on what are the what is the characteristics of the prime number. Okay, this is the prime number. This is the prime number. So I think everyone knows about this because we came across this background of mathematics. If you are completed 8th class or 7th class, you know that what is prime number if I'm not wrong. So a number, suppose is the number is there. This number can be divisible by 1 or itself. Okay, it can be divisible by 1 or that number itself. Okay, apart from that, if you are able to divide that, you can do the division, then it will not be a prime number. Suppose if you see, if you take the consider example 6. So so you can do 6 divided by 1. What will be the remainder? So you should check the remainder. Okay, you will get the remainder as 0. And again 6 divided by 6, okay, you will get the remainder as 0. Remainder, you should focus on the remainder. Okay, you can divide properly until you got the 0. But if you see what is the characteristics means, a number 6 is there. So consider, if you're just checking the number 6, so then you should focus on, okay, you should try all these things. 6 divided by 1, like, now if you want to get the remainder, what we will do in the programming world, you will do the percentile. 6 percentile 1. Okay, you need to check the output 0. Again, what you need to do, you need to check from 1, 2, 3, 4, 5, 6 also. So 6 percentile 2, you need to cross check whether it is equal to 0 or not. 6 percentile 3, like that. You should keep on checking 6 percentile 6 also. You need to cross check whether it is 0 or 1. So if you see here, 6 percentile 2 also 0, 6 percentile 3 also 0, and 6 percentile 4. Okay, what will be the remainder for these things? Okay, maybe it will also, I forgot that. What will be the remainder for this? This is 2, right? Remainder 6 percentile 4, the remainder will 2. So you should not get the you should not able to divide like this. So if you are able to get the divisible remainder is 0, then definitely apart from that, that number and the maximum number. So anyway, in mathematics, if you take any number, it will be divisible by 1, and it will be divisible by that number itself, so that we no need to check this condition. So now, suppose if you take any number like 6, we should write the logic to check the number 2, 3, 4, 5, right? 6 we need to check because we know the output clearly for any number. So if it is happening for any number, you can skip that logic. So now you should try to divide a 6 percentile 2 and 6 percentile 3, 6 percentile 4, 6 percentile 5. If you get at least one value is 0, then definitely it is not a prime number. So if then the prime number characteristics is, you should not able to divide uh, your number with any number from 2 to the max number minus 1. That, okay, this is the simple characteristics. Now how we can write the program, that is very important. So let me check, tell me, like, if you know, do you understood what is a prime number, what is the characteristic of the prime number? Just give me yes or no,
Yes, Anna.
everyone over in the live. If you don't know what is prime number, it's better to check prime number definition. Maybe if I didn't explain in the proper words. A prime number is a natural number greater than 1 that is not a product of two smaller natural numbers. A natural number greater, okay, even I forgot what is natural number. So I think I remember this logic, like, if you divide with any number, the remainder should not be a 0. That's a simple logic. Okay, so you can go through if you don't know those things. So here, the first take any number. So first you should take any number. Here I can give 21. It should work properly whether 21 is a prime number or not. If I give a 56, it should check properly that 56 is prime number or not. So here you can give any number as an input. So I'm just checking. So I'm giving a 17. Okay. So first of all, if I take a 17, it will be big one to understand initially. So first what I'm doing var number is equal to 7. So what is our target? I'm writing a simple if condition. If this is a big number, so number percentile 2 equal to 0. So what I'm saying, so if the number is 7, you should start checking from 2 3, 4, so on up to 6, right? You don't need to test with 1 and the last number, because always in the universal that is be 0. That's why you don't need to you don't need to check that one. Suppose if your number is, for example, if number is 18, what you need to do, you should check with 2, 3, 4, 5, like that. You should check up to 17. So any number, so if you take 187, you should start checking 2, 3, 4, 5, and the middle 87, and you should keep on checking with 122, okay, like, and 186. So you should check all these numbers, okay, just remember that point. So let's see, first take a simple example, and understand the logic, and then you can go with the for loop. So if you see number percentile 2 equal to 0, if this is happen, you can simply say that console.log, okay, console.log, it is not a prime number. So you can write the same logic for all the things. So number percentile 3 equal to 0. Suppose if it is divisible by 3, if you got the remainder 0 by dividing 2 or 3 or 4, so definitely it is not a prime number. So if it is not, if it is keep on, even you are checking with all the conditions. So because if once you check with the 2, you don't need to, if it is already true, you don't need to check the else condition. So here I'm writing simple else condition, because if it is divisible by 2, you don't need to check 3 and 4 and 5 and 6, right? That's what I'm saying. That's why you can do else if, because if it is not divisible by 2, then you can try whether it is going to divisible by 3, or if it is not, then you can go like this. Okay, 4, the same way you can write. So what I told you is 2, 3, 4 and 5. Suppose if your number is 6, you should write the logic up to 5. If your number is 7, you should write the logic up to 6. Let's see whether it is getting a, whether it is divisible at 2 or 3 or 4 or 5 or 6. So else still you have done all the things, but still you say that okay, it is not divisible by 2, it is not divisible by 3, it is not divisible by 4, it is not divisible by 5, it is not divisible by 6, then you can confirm that this is the prime number. Console.log, this is a prime number. So I'm just writing, dealing with the if condition only, then we can come with a for loop. So if you see, so what is the question? Suppose if I given a number 7, if you want to check whether the 7 is a prime number or not, the rule is you should check whether it is divisible by 2, 3, 4 or 6. If it is a number 6, you can check with 2, 3, 4 and 5. That is enough, right? So now I have written proper program for number 7. So it will check whether it is a prime number or not. So even we can debug and test it, observe properly. So don't worry. Anyway, we can write a simplest program in the end. This is for just to understand, because if you understand these things, you can write logic for any kind of program. So if I explain directly for prime number, if you by heart it, later you can't write the complex, you can't solve complex things. So if you see this is the prime number, it is working properly. Go to the sources, the put the debugger. So always, because this is a great help for you, if you are learning JavaScript, you can debug each and every line of code so that you can understand whether you are writing a right logic or not. So refresh. So if you see There's a number. So you are checking for the same number, and you are changing from 2, 3, 4, like that. So if you see, if it is divisible by 2, it will print the it is a prime number. Sorry, in that it's not a prime number. So if you see, no, it is not divisible by 3, it is not going to be divisible by 5, it is not going to be divisible by 6. Then, because anyway you have tested 2, 3, 4, 5, all the combinations, it is not divisible, so that you can conclude that this is a prime number. Fantastic. So go and see the output. Yes, this is a prime number. Okay, understood. Just give me confirmation so that I can now we can write a program for like normal number, then check whether it is giving a right output or not. Ping me yes if you understand. If you don't understand, ask me, I will explain one more time. So if you understand the if condition, also you can write the logic, but it's going to be very very tough, right? So you have written logic for 7. So in the future, if I give a 17, what will happen? So again you need to write a logic divisible by 2, 3, 4, 5, 6, up to 16. So it's really really painful, right? It's really painful. So, okay, first of all, let's see whether this logic is correct for number 6. So if you want to check whether 6 is a prime number or not, what is the condition? You should test by doing the division 2, 3, 4, 5. So you don't need to check this one, right? Hopefully you are aware of this clearly. So still, if you are not able to write a if condition, don't worry. Just ping me in the chat or somewhere, sir. I'm not able to write a if condition. I'm not able to understand if else also. No problem. I will give more and more examples on that so that you will familiar. Then you can jump into the next topic. So fine. Now what we are doing? We are checking. We are checking with all the combinations. All the combination. So first we will check with 2, 3, 4, and 5. If it is luckily if it is divisible by 2, here itself we can conclude that it is not a prime number and it will come out of that block, if block. So now let's see. I'm just refreshing and go to the sources. So now this is number is 6. Okay, I just override here, no problem. So just check what is the number 6. We are testing for 6. So if you see number percentile 6 percentile 2, it is equal to 0. So in the first line itself, first the condition itself, we can understand that it is not a prime number because we are able to divisible by 2. The remainder of 6 percentile 2 is equal to 0 quickly. So that what will happen? It is going to print this is not a prime number. Simple. So you don't need to check all the other conditions because in the first condition itself we are able to understand that this is not a prime number. Okay, this is the simplest one. Okay, I hope you guys understood. Now the thing is, now the thing is, because this is difficult because every time, suppose if I give a number 6, you need to change the program. First number 7, again you need to add one more condition. Suppose if it is 178, suppose if it is 178. So what is the problem? You should write these if else blocks. Okay, how many if else blocks needed? For 6, we need 4. So 178, you need to write 170. If it is like what is the number minus 2? So if it is 178, you should write 176 if else block. Suppose if I give 2178, what you need to do? What you need to do? We need to do. We need to write 2176 if else condition. So it's really really painful. But here you need to understand that what is the common logic? What is the common logic? If you see, this is the common logic. If you're giving a number and you are divisible by some number, the condition also same, like double equal to 0, then you are writing it is not a prime number. So almost in the all the if conditions, everything is same, everything is same, only one value is changing. That is 2, 3, 4, 5, right? This value is only changing. Number same, double equal to, condition also same, 0 same, and statement is also console.log. It's not a prime number, but only in one situation we can conclude that it's a prime number, so we can handle it easily. So now this is changing so that in this situation you can utilize the power of for loop, because we no need to change program for each and every number. So the only value is changing, the only variable is 2, 3, 4, 5. So that we know, right? For loop, we can write a for loop and start we can control the what is the start number, and we can control that from which number we need to rotate the loop. So if you understand these basics, you can write any, you can solve any complex program. Okay, so I can talk in Telugu for 2 minutes because it's easy to understand by the Telugu people. సో మీకు చూడండి, మీ నెంబర్ ఉంది. ఓకే, ప్రైమ్ నెంబర్ అంటే ఏంటి? సపోజ్ 17 ఉంది కదా, 17 ఉంటే అది 1 తో కానీ 17 తో కానీ, ఈ రెండు నెంబర్స్ కాకుండా మిగతా ఆ మధ్యలో ఉన్న ఏ నెంబర్ తో అయినా ఓకే డివైడ్ చేసినప్పుడు దాని రిమైండర్ కనుక 0 వస్తే దట్ ఈస్ నాట్ ఏ ప్రైమ్ నెంబర్. సో అందుకేం చేస్తున్నాం మనం? సపోజ్ చూడండి లాజిక్ లూప్ ఎలా ఎలా ఉంది. సో ఎవ్రీథింగ్ is started from 2. So every logic you need to start the for loop with 2, and you can end with this number minus 1. Observe carefully, number minus 1. So I can write here so that you will understand how to write a for loops. So if it is a number 7, if it is number 7, what you need to do? You should start with the index number will start with the 2 and it will end with the 6. Okay, same, that means it is a number minus 1, right? This is maximum number minus 1, maximum number minus 1. So same thing, if it is 17, what will happen? It will start from 2. We should keep on rotating the for loop until 16. So that means 16 is also maximum number, that number minus 1, so that we can write for loop easily. So because index number is starting always with the 2 and we need to check the condition always up to number minus 1. So it's very easy. So if you already understand the for loop, it's not a big deal for you. So if you see, I can replace this thing for that one, but we should write slightly some, add some other logic also. So for what I'm writing for where I equal to 2, because I'm starting with the 2. So some few people start with 0, 1. So you don't need to test with 0 or 1 or the same number, because if you try to divide with 0, it will go for infinite the value, and if it go with the 1, always its remainder is 0. If you go with the same number, always the remainder is 0. So here the condition is I less than number, right? So it will check up to a number minus 1. It is valid up to the maximum number minus 1. Otherwise, few people will do like I less than or equal to number minus 1. This is also fine. There is no difference between I less than number or I less than or equal to number minus 1. So it will, the meaning of this both the thing is same. So if you understand mathematics, I plus plus. So I always prefer to use simplest one. So I less than number is a simple one, because if I value become equal to number, the for loop should break and it will come out of that. So here if you have a 17, if the I value number 17, 17 less than number, so 17 less than 17, it's false, so that it will break. So we no need to test 17. So we need to test until 16. So it will be a perfect for loop. So now here what we need to do, the many students written like this. So if you see, many people have written like this, number percentile I. This is perfect. Up to this they have written properly. So if number percentile I double equal to 0, it is not a prime number, and people have written something like else. Okay, if it is not divisible by I, they have written console.log. This is a prime number. So this is wrong. Okay, so let's see. Of course, whenever you try to convert normal if condition to for loop, okay, so sometimes, okay, there is a chance to do mistakes. Okay, so I'm just giving this one. So don't worry. Slowly we can understand how to write a proper code. So if you see, looks like if you convert that if condition to this thing, we thought that this is the right program. But always just check the output. So here what we are doing if, okay, I think most of the students, like few of students written like this. Let's see, we can debug and test the output. So go to the sources. Okay, I have given 2188 78, no need. So I'm giving number 7. What I'm giving, I'm just testing with the number 7. So go and refresh. So start doing division. So number, if you see, if you write like this in a for loop, it is just checking the first condition. That means 7 percentile 2 equal to 0. Definitely it will be a false. Immediately you are going and check displaying that this is a prime number. Okay, if you see the output, you have concluded that this is a prime number. Just you have checked the first condition. So in this logic, what you are doing, if 7 percentile 2 equal to 0, this is the if condition. So okay, until this point logic is correct. So this is not a prime number. So but if you by mistake if you write else here and you can conclude that this is a prime number, means what is the logic you have written? So you're just checking with the one number and you're concluding that it's a prime number or not. So this is a blunder. So one minute, I will tell you in Telugu. So మీరు చూడండి ఇక్కడ మా ఇందాక రాసిన లాజిక్ ఏంటి, మనం we should always check from number 2 till the number minus 1. Suppose if it's 7, you should check 2, 3, 4, 5. So you need to test all the things. Then only you should conclude that whether it is a prime number or not. So you can't conclude by checking the first condition. So 7 percentile 1 double equal to 0. It is false. After that, you can't decide that it's a prime number because you need to check with 3, you need to check with 4, you need to check with 5. That should also happen. That's why we can't conclude here itself that this is a prime number. But how can we solve this question? So if I don't put a else condition, how can I decide? Here you should think smart. So what is our goal? So now again I will write a program simplifying. So we should think like this. So I'm just checking 7 percentile 2 double equal to 0. So right? So any number, if you want to check it is a prime number, you need to check with 2, 3, 4 until the number minus 1. So you should not able to divide that number with these numbers. So the count will be 0. What is that count? How many numbers, with the help of how many numbers you are able to divide this number properly. So if you got that count is 0, then you can conclude as a prime number. Suppose 6 is there. 6 is there. 6 you can easily divisible with 2. That means the count will become 1, right? Count will become 1. So if the count is 1, you can say that this is not a prime number. You need to check with the 2. So then you can divisible with 3 also. So the count is 2. So no problem, because if count is greater than 0, you can conclude that that is not a prime number. So what is the prime number criteria? If you divisible with any number from 2 and the number minus 1, the count should be 0. Count should be 0. So here we can take one flag as a count and we can check the count. Then we can decide later whether it is prime number or not. So here I'm writing the logic so you can understand later. So here immediately I can't decide whether it is a prime number or not. So what I'm doing here, simply where I'm putting a count, initial count is 0. So if you are able to divisible with any number, just increase the count. Count plus plus means it will do count increase by 1. Okay, if this count value is 0, if you execute this statement, what will happen? The count will become 1. If the count value is 1, if you execute this one, count will become 2. Simple. So leave that for loop. Leave that for loop. This for loop will check all the numbers. Number divisible by 2, number divisible by 3, number divisible by 4. If the number is 7, till the I value 6, it will check whether it is divisible with that number or not. It will check the remainder is 0 or not. It will just store the count. Okay, how after completing the for loop, you will get the count of the numbers, how many times it has divisible with in like all that combination. So if you got this count is 0, simply you can understand that okay, this number is not divisible by any number from 2 to the number minus 1, so that you can conclude a prime number. So here after that you should write if condition. If okay, count end of the after completing that for loop, after completing the for loop, just check if count equal to 0, console.log, you can conclude that this is a prime number. So this is like simple. Suppose if you want to be successful, what I'm saying, you should attend all the session. You should attend all the sessions. Every day I will check the attendance. Every day I will check the attendance. Your count, like how many times you miss the class. Every day I will take the attendance. Suppose Balavardhan on today, like November 21st, he didn't attend the session, so the count will become 1. So what is the rule? If you miss one session, you can't succeed like that, if that rule is proper. So I'm always checking the condition. I'm always checking your count, how many sessions you have missed. So if you miss more than 0 number of sessions, there is no guarantee for the success. So here also same. What we are checking? We are checking the count and we are storing in a separate variable. After completing this for loop, you will get the count, how many numbers. So you can say that here 1 2 4 5, whatever, no problem, you can give any big number. So it will check all the numbers. Suppose 1 2 4 5 7. So it will check this number divisible by 2 3 4 5 6 100 200 300 1000 10,000 12,455. So the loop will rotate 12,455 times and it will check the count, how many times it has allowed to divide with the remainder is 0. So if still the count is 0, then only we can say that this is the prime number. Else, because no problem, if you miss one session, there is no guarantee for the success. Here also, if you divisible with by like any number at least one time, simply whether it is 1 or 100 times, there is no problem. So we can conclude that this is not a prime number. Okay, so for you, I will put a console.log. Okay, I will display the count also. Count colon so that we can understand that how many times it has tried. So we can go with a simple number 6. So refresh, you can see. Okay, what you are doing right now, the count value is 0. Observe carefully. Count value is 0. So now what we are doing, we are in the for loop. We need to check number 2, number 3, number 4, number 5, and number 5. Then it will break. So this just debug. So now it is testing with 6 divisible by 2 equal to 0. That is true. That's why the count has increased. So, so if you see, the count value is 1. So still what we are doing, we are testing with all the numbers. All the numbers, go test it, test it, test it, test it. So I'm just putting another breakpoint here. If you want to jump directly, if you want to complete that for loop from this breakpoint to, it will jump to another breakpoint. If you just click on this one, step out of the current function or a logic. Now of end of the for loop, so the value is 2. That means the 6 divisible by 2, the remainder is 0, and 6 percentile 3, the remainder will be 0, 6 percentile 4, the remainder is 2. So we got one time it is divisible by 2. So then we can conclude that this is not a prime number. So if you see, the count is 2, that's why this is not a prime number. You can see the output count. So now you can do with for 17. So for 17, we know, right, from number 2 to 16, it will check up to 16. If you got that count is 1, then we can say it's not a prime number. But for this program, definitely you will get the count is 0. Refresh sources. So if you see, so what I'm trying to say here, right now you are in for loop. So if you want to come out of this breakpoint to the next breakpoint, you should use this one. Okay, step out of current function. Just click on it. So it will finish the for loop and it will pause here. So you can check the count. Count is 0 because for number 17 you have tested with number 2, 3, 4, 5, 6 up to 16. Still the count is 0 because no one, you didn't miss any session. So count, still the count is 0. Then simply you can say that you will succeed 100%. Console, this is a prime number. So you can test any number now, any number. 117. So I don't know whether it is a prime number or not. So I'm just removing that breakpoint so that we can test it properly quickly. Okay, refresh console. Okay, this is divisible by 4 times, so that this is not a prime number. So and then 1217. Let's see how many times it has done the divisible thing. Oh, 0 times. This is a prime number. Wow. So if you see 1217 is a prime number, if you want, you can cross check whether the logic is right or wrong. Okay, hopefully, I'm not sure whether you guys understood or not. So if you don't do practice, definitely you can understand. If you do practice multiple times, you will understand. So let me know that understood or not. Everyone, give me yes or no or I don't know kind of thing. Okay, What about Omkar? Varshan? Okay, Varshan said yes. Balajan said yes. Rajendra said yes. How many people are there? Deepak, what about you? Omkar? Srijan? Okay, suppose if you have any, if you don't understand, ask me which one is very complex for you. Maybe you will get a confusion that why we need to take count here. Like so, just stick to the basics. సో ఐ విల్ ఎక్స్ప్లెయిన్ తెలుగు సో మీరేం చేయండి ఒక నెంబర్ తీసుకోండి ఆ నెంబర్ని టూ నుంచి ఆ నెంబర్ కంటే ముందు నెంబర్ వరకు ఓకే పర్సంటైల్ టూ మీన్స్ ద రిమైండర్ చెక్ చేయండి ఆ రిమైండర్ ఒక్కసారి కనుక వన్ టైం ఒకవేళ మీకు జీరో వచ్చినట్టయితే డెఫినెట్లీ ఇట్స్ నాట్ ఏ ప్రైమ్ నెంబర్ సో అది ఒక్కసారి కూడా డివిజిబుల్ కాకుండా జీరో అయితే ప్రైమ్ నెంబర్ అంటాం ఇన్ కేస్ ది కౌంట్ ఈస్ వన్ డెఫినెట్లీ ఇట్స్ నాట్ ఏ ప్రైమ్ నెంబర్ సింపుల్ లాజిక్ okay that's why the logical thinking everything is important for a programmer so slowly okay if you are a beginner don't worry take your own time first understand the if condition if else and write for loops for simple thing like displaying number 1 to 100 in the reverse from 100 to 2 once you are strong in for loop so you can try to understand some complex examples okay so now this is enough for today so I will stop the live I want to discuss okay I can cross check how you have done a practice for last 2 days in the Microsoft Teams okay bye bye people who are there in the live see you tomorrow and don't miss any session I'm saying if you miss one session definitely there is no guarantee for the success because the programming is something different bye bye